This video is about the normal distribution. I'm going to explain z-scores and how to calculate percentages based on z-scores. So at the top of the page here, I have a normal distribution, and it's set up with the 68, 95, 99.7% rule. And what this means is that within one standard deviation of the mean, 68% of your data falls within that range. Within two standard deviations of the mean, 95% of the data falls in that range. So we're going to use that fact to answer the first question. The background here is that the average temperature for April 6th in my town is 50 degrees with a standard deviation of 10 degrees, and we're supposed to assume that temperatures are normally distributed. So question 1, based on this, says, what percent of the time would you expect the April 6th temperature to be less than 40 degrees? All right, 40 degrees is 10 degrees less than 50, so it's one standard deviation below the mean. If we were looking at the graph, it would put us right at this point here. Now the total under the distribution here is 100%, so I want to figure out how much percentage lies to the left of -1 standard deviation. And to do that, I know that there's 68% from here to here. So if I take 100, subtract 68, and then divide by 2, that'll give me the left tail. All right, so that's 16%. And that's the answer to our question. 16% of the time, we would expect the April 6th temperature to be less than 40 degrees. All right, the next question here is, in what percent of years would you expect April 6th temperature to be between 30 degrees and 70 degrees? So if the average is 50, then 30 is 2 standard deviations below the mean, and 70 is 2 standard deviations above. So looking at the graph here, the answer is directly available from the graph. 95% of the time, or in 95% of years, we would expect the temperature for April 6th to be between 30 and 70 degrees. Now this general rule of 68, 95, 99.7, that works well if it's exactly 1, 2, or 3 standard deviations above or below the mean. But if we have a temperature like 42 degrees, which is not an even standard deviation, then we should use a z-score. So this question is, what is the z-score for an April 6th temperature of 42 degrees? So that's 8 degrees below the average. The way that we calculate a z-score is z is equal to our data point, 42, minus the average, and then divided by the standard deviation. And type that in. And I get -0.8. The negative is important here. The negative tells me that this temperature is below the average, and the 0.8 is saying that it's 0.8 standard deviations below the average. Now this question doesn't ask anything about a percent, so we'll just leave it there at -0.8. But if we go on to number 4, it says, what is the percentage below 42 degrees? So we knew that the percentage below 40 degrees was 16%. We would expect this to be, a little bit more than 16%, and we'll find out exactly. So for 42 degrees, the z-score is -0.8. And if you go in your book, there is a table that has the z-scores and the percentiles. So I'm going to look up -0.8. And where is it? All right, it's right here. -0.8 is at a percentile of 21.19, So that's what that's saying, is that 21.19% of the time the temperature would be less than 42 degrees. All right, and the final question here is, what is the percentage above 42 degrees, or what percent of the time is the average temperature on April 6th above 42 degrees? And to do that, I will take 100% and then subtract 21.19. And the answer here is 78.81. All right, so that's how you calculate z-scores and then use those z-scores to figure out percentages. If you have any questions, please let me know.